What's going on, guys? In this video we're going to cover some alkene and alkyne nomenclature techniques. We are going to be using bond lines, so if you're not familiar with bond lines, go check out my previous video and then come back to this one. Naming alkenes and alkynes can be more difficult if you're dealing with structures with more than two carbons on the carbon chain, because how do you specify the location of the double or triple bond? So if someone said they wanted you to cook them up some octene, alright, you know there's going to be 8 carbons on the longest carbon chain. You know there's going to be a double bond. But where's the double bond going to be? Is it between these two carbons, these two carbons, these two? You just don't know. Well, to identify where the double bond is supposed to be, you're going to number your carbons. Let's start with an example here. Alright, so there's 3 pieces of information we need to pull from this in order to name it. 1, parent name. 2, suffix. So what kind of compound are we dealing with? 3, location. So parent name, that's easy enough. We just have to count our carbons. So we have 1, 2, 3, 4, 5. Parent name is going to be pent. So what suffix do we attach to that? Well, double bond, that means we're going to be dealing with an alkene. So our suffix that we'll attach to pent is going to be -ene. What about the location? Well, that's where a little bit of techniques come into play. So we have to number our carbons in order to identify the location of the double bond. And you can do that from one of 2 directions. We have 1, 2, 3, 4, 5. Or you can go the other way. 1, 2, 3, 4, 5. Well, that's kind of confusing, because then the location of the double bond is dependent on which way you drew your numbers. So the way you do this, always make sure your double or triple bond is assigned the lowest possible number when numbering your carbons. So numbering this way, our double bond has a 2 and a 3. Numbering this way, our double bond has a 3 and a 4. So we're going to erase the top part. We're going to roll with the bottom part. So there's a 2 and a 3 associated with this double bond. Which number do you use to describe the location? You're always going to use the lowest number. So location is 2. So to put that all together, all you do is write the location of the double bond, 2, with a dash, and then combine the parent name and the suffix. So pent, -ene, pentene, 2-pentene. So this is the same as this. Let's try it in reverse this time. Let's start with the name of the compound and draw the structure. Alright. Let's say you're given 3 octene on paper and you're told to draw the bond line structure. Well, let's take our 3 pieces of information from here. 1, the parent name is oct, so we know there's going to be 8 carbons on the longest carbon chain. 2, what kind of compound is it? The suffix. Well, octene, so we know we're going to have a double bond somewhere. 3, location. We know the double bond starts at carbon 3 and it'll end at carbon 4. So now all we have to do is make this information into a bond line structure. So 8 carbon chain, so we have to draw our 8 carbons. 1, 2, 3, 4, 5, 6, 7, 8. Let's number our carbons. 1, 2, 3, 4, 5, 6, 7, 8. Now, just have to place the double bond. So our double bond is in between carbons 3 and 4. Like that. And it's really just as simple as that. Let's move on to Alkyne nomenclature. And if you get the hang of alkene nomenclature, it's the exact same thing, except the suffix changes. Let's start with let's start with this compound. Well, still have to take our 3 pieces of information from it. So 1, parent name. How many carbons are in the carbon chain? 1, 2, 3, 4. So our parent name is going to be bute. Beautiful. Alright, 2. What kind of compound is it? What suffix are we going to attach to bute? Well, we see here there's a triple bond, and triple bonds are alkynes, with the "-ine" being the suffix. So there you go. Alkyne is our suffix. What about the location of our triple bond? Well, we numbered this already to assign the triple bond the lowest numbers, and we know that when describing location, you always pick the lowest number of the 2. So the location is going to be 1. Now bringing all that information together, simply going to be 1 butine. Alright, we'll do one more example in reverse. Might be overkill, but repetition's always good. Let's say on a test you were given 2 heptine and you were asked to draw the bond line structure. Well, let's take our information, hep. So we know there's going to be 7 carbons. 2, what kind of compound are we dealing with? Still a triple bond, -ine. So we're going to have to place a triple bond somewhere on our 7 carbon chain. Location. So 2, we know it's going to start at 2 and end at 3. So there's going to be triple bond in between 2 and 3. Now all there is left to do, combine all the information. So 7 carbons, 1, 2, 3, 4, 5, 6, 7. Let's number them. 1, 2, 3. Now, just place your triple bond between 2 and 3 by placing 2 lines there. And you're done. It's as simple as that. That's it for alkene and alkyne nomenclature. In future videos, we're going to add some functional groups and do a little bit more complex naming, but we'll see you next video.